All right, so I had the pleasure when I came into Puppy today to meet with Joe and with Nathan and with Hannah. So many great, very talented people here. Let's give a round of applause for everybody here. And for all those who just recently graduated, round of applause.
Here, Luke.
Can everybody hear? Cool.
That is not actually a broadcast microphone.
Oh, no, it's not? Hey, we'll give it a shot, right? So today we're going to talk about bits and bytes for all level coders, and it's going to be both Chinese and in English. So it's going to be a lot of fun. All right, so we're going to first start off with our history about bits and bytes, known as the Lu Shi. So it all started with Gottfried, who was actually the founder of bits and bytes back in the 1600s. And he was the man who actually invented calculus and the binary system. And so later on, when we go on to in the 1940s, we have Claude Shannon, who was the inventor and cryptographer of the first ever bits. And so that was when computer science was starting to kind of get its step into the industry. And we have then later on in the 60s, IBM was becoming a big thing. It was like the Microsoft nowadays. And so Werner Boltschus, he actually was the inventor of bytes and made it to where 8 bits equals 1 byte. So it kind of makes it easier for computer scientists to like differentiate. And he also was well known for designing the IBM Stretch, which back in that day was a very popular computer. And so what are bits and bytes? So bits are zeros and ones. And bits represent the smallest digits of information. And so bytes include bits. And as said before, 8 bits equals 1 byte. If you want to know something fun in Chinese, 1 bit actually is bi ce, and then 1 byte is 4 jie. And so, 我们要怎么计算bi ce和4jie呢? So we're going to start some problem solving. And so here, what I just said in Chinese was, let's get ready to problem solve. And just in case if anyone just wants to learn, but this here is really cool. We're going to start off with our very first binary number system, which I always love to do. So like here we have 1 0 0 0 0 1 0. So how do we figure out this binary number system? Well, when you think about it, we start from the right and then we go to the left. And we take it with the, and we multiply it by 2. So we start up with 1 here, and then we go 2, because 1 times 2 is 2. So 2, and then 4, 8, 16, 32, and 64. And so we got our numbers, but how else are we going to do with those numbers? So whichever number is 0, surprisingly, it doesn't get counted. And so we're going to count just the ones. So we'll count 1 and we'll count 32. All right, what are we going to do with 32 and 1? Well, we're going to find out. So our mission here is we got to add 32 and 1, because then 32 plus 1 is then going to equal 33. And that's how we figure it out. The question?
Is that 33 factorial?
Oh, 33 factorial. You are correct.
I knew it was going to be you.
You're awesome. Save the day. And so we got now our ASCII table. It gets even more creative, you guys. So what ASCII value does this binary value belong to? So we got a different one. So we have 0, 1, 0, 0, 0, 0, 1, 0. All right, so we can go a little higher than 32 or 64 this time. So we got 2, 4, 8, 16, 32, 64, 128. So in this case, we have 64 here and 2, so we just add those two, we get 66. In this case, though, we gotta then look in our ASCII table. Dun, dun, dun. It kind of, funny thing, reminds me of chemistry a little bit. But we're gonna take the 66 here, and then we're just gonna match it with the letter there, and B. So technically our B would be our ASCII value in that one. All right, 比特和世界类型. So here's our types of bits and bytes. So how are we going to memorize these terms? Well, you think about kilo, that's 1,000. So kilobit, 1,000 bits, it equals 1,000 bit. And megabit, that's 1 million bits, 1,000,000 bit. And then gigabit is equal 1 billion bits. It's going to be 10亿 bit. And then terabit is equal to 1 trillion bits. That's a lot of bits, guys. It's going to get even more. And that's going to be 1兆 bit. And then petabit, which that is actually equal to 1 quadrillion bits. And that's going to be 1,000 兆 bit. And so,
That's a good question.
so here's a good question that I think is going to help us kind of get in the feel of, oh, sorry.
Here and on the last, it's kind of like a plus minus at the start. Is that
Yeah.
just a Chinese
No,
character,
actually,
or
it is a
that-
Chinese character.
Oh, okay.
So that actually means 1.
Oh,
Because when you look at the Chinese numbers, the first number is actually, it's kind of like, it looks like a minus sign. It's kind of an interesting thing. But here, so we have, this is kind of give us a feel on like how we can memorize these. And so like, for this one here, I have a question for you guys. What does kilobit stand for? Do we have any volunteers?
1,000 bits.
1,000 bits, you're correct. And then how about a petabit? Quadrillion, yes. You guys are awesome. And then another thing I want to talk about is, so the conversion with bits and bytes, it's pretty simple because you think about like, if we want to do the kilo version of bytes, we just do kilobyte, which that's going to equal 1,000 bytes. Megabyte, 1 million bytes. Gigabyte, 1 billion bytes. Terabyte, 1 trillion bytes. Petabyte, 1 quadrillion bits. Or bytes, actually. I should change that. And so this one here, so we're going to learn some fun facts about the bits and bytes. And so first of all, the human brain has approximately 2,000 terabytes of memory. 大脑有练建造世界的记忆. And so when you download one song on your device, it will take up 3 to 4 megabytes of code. 你在下载一首音乐时候，它会将用3到4百万世界的代码是空间. And so 1 megabyte actually equals 1,048,576 bytes because it is rounded and measured by 10 out of 24 of a byte. It's a lot of information, guys. So if you have any questions, feel free to raise your hand.
I have it might be a stupid question.
Yeah.
Is that a logarithmic scale, bit, byte, kilobyte, megabyte?
Yeah, so this guy here, it's kind of like a pyramid. Sort of, I guess, like we can call it algorithm too, because it's got like, the bits is like technically the smallest, and the byte is like the second, like the biggest, and then it kind of goes bigger down the chain there. And so, so that one, those are some kind of fun facts. And how many of you guys seen the new Tom Cruise movie, The Final Reckoning? You seen that? Seen it? Nice. I love the movie personally because I like the ending where Tom Cruise, he's trying to save the world by using an SD drive to put AI inside it. And so I think that's pretty cool because like it's technically like 360 terabytes. And so I'm like, that is awesome. Like good for you, Tom Cruise. And he does a great job in the film, and also in Chinese his name is Tamu Kulu. And so I find also very interesting. And so you think about like, all right, so 360 terabytes, yeah, that's a lot of memory. How much memory does like Microsoft, Amazon, or Google store? And usually when I was doing some research, they only store around maybe 30 terabytes in data centers. And so you think about the future, what does the future behold for us? Like maybe we are able to then hold 360 terabytes into an SD drive instead of having to rely on fiber optic cables. It's something that we could think about. And so we have a little pop quiz. And let me know if I ever go too fast because I want to go at your guys' pace. So do fiber optic cables use short intermittent sound waves to transmit data? Can anybody guess?
Well, they use light.
Let's see here. You're correct. It's false. And next question is a twister pair Cat5 cable made of copper true or false? All right, a lot of trues on that. You guys are right on. All right, and that does it for my presentation. I just want to wish you all a wonderful rest of your time here at Solemn, and thank you for listening. 祝你有愉快的一天。